In the previous movie, we added the ability to squash and stretch our torso. Since this completes all the functionality we need, this movie will focus on incorporating the torso into the character rig we're progressively putting together. Start by opening the file Character Rigging, Part 6 Start, or by using your own file from the previous lesson. Before we start thinking about the whole character though, we need to include one more control. Notice that although we can control each portion of the torso separately, we're lacking a way to manipulate the entire upper body. Let's go ahead and build a control for this. Create a polygon plane, translate it up to the hips, and scale it to make it larger than the hip control. Now create a linear EP curve with point snapping to trace out the edges. Refer to part 3 of this series if you need more help with this technique. Delete the polygon plane. Rename the curve Body Control then snap its pivot to the hip joint. Change the rotation order to ZXY. Select all the parts of the torso we've created so far and group them into a torso group. Parent constrain this group to the body control node. Now we can manipulate the entire torso by using just this one control. Except when we do that, notice how the result joints and geometry move out of sync with the FK joints. This is because they're actually being transformed twice. Once as the controls are transformed as part of the group node, and again as the IK spline curve itself is affected by the group's translation. Here we want the spine curve to only be affected by the former, so select it in the attribute editor and turn off its inherits transform attribute. Now the curve won't be affected by any parent transformations in the hierarchy above it. The body control curve is the highest control in our rig, so let's put it in a layer of its own, named Body Layer, and color it red. The next thing we should do is hide all the nodes we don't want animators touching. It's our responsibility to make sure they only use the controls we've designated for them. Otherwise they might break our rig. As such, select the hip bind joint, shoulder bind joint, spine curve, spine handle, and result joints, and group them together. Rename this group Do Not Touch Group to make it very obvious for any animators. Just like we don't want to expose nodes that could break our rig, we also don't want to expose any errant attributes either. For example, the scale attributes on all our controls shouldn't be touched. So we're going to lock and hide them by right-clicking them in the channel box. Additionally, we aren't concerned with the translation or radius values of our FK controls, only their rotation, so we will lock and hide these attributes as well. As for the FK joints without controls, it's best to lock everything on them. Finally, we should lock all the transformation attributes for the FK constraint groups and torso group as well. We'll leave the visibilities unlocked for the controls and torso group as a whole for now, as we'll make use of them in a later lesson. Now animators can only modify the attributes we want them to modify. As a final bit of tamper-proofing, let's select all the torso geometry objects and put them in a new layer called Geo Layer. We can change this layer to reference mode so animators won't accidentally pick geometry when they actually want the controls. We should do the same with the result skeleton by adding it to a new layer named Result Skeleton Layer. We'll change this layer to template mode to make the joints semi-transparent. Let's also hide the spine curve and spine handle from the workspace so animators don't accidentally select them. Now we need to turn our attention to how the torso fits into the rig as a whole. So far, we've developed our torso in the root of the scene, also known as world space. However, if we imagine our character as just one object in the scene, then we need our torso to exist within that object, also known as object space. Torso group is just for our torso. Assuming we eventually end up with other appendage groups, we'll need to wrap those all up in a group that represents the entire character. Select both the body control and torso group and press Ctrl G to create another group node, this time calling it Emma Root Transform Group. Set the rotation order to ZXY, just like our torso. Now we can use this root transform group to place and move our character in a scene, while still being able to manipulate the character's individual body parts, for now just her torso, within the character herself. However, although both translation and rotation on this root node work great, notice what happens when we try to scale it. The torso completely deforms. Is it any coincidence that the area that's messed up is the same area we added squash and stretch to? No, of course not. The problem is that as you increase the scale of the root node, that in turn increases the scale of the spine curve. But remember, the length of the spine curve drives a network of nodes that controls the stretch and squash of our torso joints. In other words, the spine thinks you're stretching it when you really aren't. To fix this, we'll need to make sure the percentage of stretch doesn't change when we scale up our root transform node. We can do this easily by feeding the value of our root transform node into that very calculation. Select the spine curve node and open the node editor. Our goal is to normalize spine curve's length by the time it gets to the spine stretch div node. To do that, let's create another multiply divide node. Rename it Global Scale Spine Normalize div. We'll feed spine info's arc length into the input 1x attribute. Then middle drag the Emma Root Transform group node into the node editor and feed the Scale Y attribute of the Root Transform node into the input 2x attribute of our new multiply divide node. Set operation to divide so that when we scale our character up, this will output a normalized version of the spine curve's value. We can feed this into the input 1x attribute of our original spine stretch div calculation, replacing the current connection. Close the node editor and try scaling the root node again. Everything scales as we'd expect. Let's add a control for this as well. we'll make it a scaled-up NURB circle. As with the FK controls, name the circle EMMA root transform control. And use the parent-r-s command to parent the shape to the EMMA root transform group node. Delete the leftover group and rename the root transform to control. Finally, we'll add the shape node to the body layer. Now that we have one full body part done, let's take a moment to review all the requirements we needed to meet in order to have a functional rig. First, the controls need to be simple and easy to use. And they need to be zeroed appropriately. Local rotation axes need to be set, and rotation orders need to make sense for all controls. Nodes and attributes that could break the rig need to be hidden away. And finally, the rig needs to transform correctly in its own space, as well as in the character's overall space. Perfect! Our torso rig meets all these requirements, so we can turn our attention to another body part. In the next movie, we'll start work on the head and neck.